tell the system to wake up once you touch it or something. It's ready to execute the code for you. So it's not necessarily going to stop at this point. You may have it looping in. So you have a start, you have a finish, and then you have expressions that will go in boxes and statements that will go in there. So this particular one is mostly used for decision making, right? So is Michael still talking? Yes. If yes, then you branch to a particular side. So it's just used for decision making, you branching at that point. If no, then of course you branch to another side as well. Okay, so you've got branches that you use. In this particular case, we've got a true and then the false options on there, and then this is the next state that you're actually landing in, which is where your code will be sitting. Please, please, please don't just simply draw these boxes and paste your code in there. It should be easy. It's like algorithm flow or writing down your algorithm. It should be easy and it should be interpretable to whoever wants to repeat your code, right? They are like comments. It doesn't necessarily have to be exactly the same code. We understand at this point we are branching, we're making a decision making. So we've got statement, of course, if it is true, and we've got a statement if it is false, and then we reach the stop, right? Cool, so far so good. Then people may have heard of a switch case statement where you run a switch. These are just superficial examples. So you do run a switch on a particular variable, let's say variable x, simply means that we are looking at the value of this variable, and depending on the variable's value, maybe case where the value is 0, we'll do something, or case where the value is 1, we'll do something. It's like if-else condition, but basically people prefer it because it's much cleaner, right? So we say we have our starting point, and then we have our end point again, and we have a statement that will execute just before we end, right? In this particular case, we come back to a decision. So we're looking at the variable's value. So we have the switch case condition that we are running, and we say condition 1. If condition 1 is met, do something, and then you have maybe a break, which means get out of the loop and then or go straight to the next statement before the end. And then you have condition 2 again. If condition 2 is met, do something, then go on. Else, of course, you check again all the way to the last condition before you do something. But then there is always a default. After the last condition, if the last condition is not met, then the default condition will be run to take us to the next level. You can take this as a template to plug in what your conditions are, what you are testing on this particular point, what statements you are running, and these if this switch statement form part of a bigger flow, of course it's going to plug in as part of the bigger flow. It's just not going to sit on its own like that. But then you have a lot of people who also maybe make a link to a label flow, let's say A, and then they will come to this particular point and continue A from there. Then if this flow also feed into another flow because you are running out of space, then of course it can be something like B here, and then you go to another diagram and start from B flowing on there. But you just have to make sure that it makes sense. It's like working with algorithms, really, or pseudocode. So the common blocks that are used, of course, this goes on there, just been truncated, and I can draw a straight line. We've seen the process, but similar to statements. You've got alternative that you can use on there. We've seen the terminals, which is like the start and then the stop. We've seen the decision-making database. Of course, you wouldn't need it for this point in time, or my work. Some people may put delays or choose not to use it, or simply use this. You've got another diagram for input. So you just use this as your reference. And we notice where we just on-page reference, we just use a similar thing to jump on from the A-B thing that we did before. So you want to use this as a reference point, spend some time on here, just see how each component is actually working and how you can make use of them in your flow diagrams when you start drawing them. So now we want to have a look at some of the common flows that you will use for the well-known programming sort of structural techniques such as various programming concepts, right? So if you want to make a decision, so if the value is 1, do something else, do something else. So we just check, is the code outside? If yes, then we implement something. If no, then we jump straight on to a step, or we skip a step. So this is more like an if-else, an if statement flow. Then we have another look. So we have the same if, makes life easy. Another example where we say if the average is greater than 95, then say congratulations, you have a high score, right? This can be maybe a game, or it can be students' mark or something like that. But remember, you need to make sure that you label these, right? Whether you're yes or no, true or false. If they are missing, it's hard for whoever is reading your flow chart to understand what you are trying to implement. Then you have, normally what we executed before was just simply if x equal, an example, if x equals 5, then we run a statement, maybe x equals x plus 10. And then we move on to the next. But then there may be case where we say, okay, what if x is not equal to 5? Then what do we want to do? We've seen a similar thing as the switch. Why am I writing else? Right? Else maybe do something, or we can also check in some cases else if. And of course, if this was Python, it would be elif, right? Else if do something else, or else if another condition is met, do something, or then eventually else do something else. So the else if is just going to be quite similar to the switch case you looked at, but let's look at if and then else. So we have if it is true, then we have another statement, else do something else. The one we saw earlier without the else part, this block was missing. So we're just building on it to have our if-else condition work. And sometimes you can have a statement like this. Let me just simply make it if x, okay? And within the statement that is meant to run, you can have another if statement. We are not diving into any coding yet. It's just a concept and how we represent the code using flowcharts, right? Or we can go in there if x is it, and we say if x is greater than 10, do something. So this will work, and we'll check on condition if x is greater than 10. So an example on here, how we do that. We reach the first decision point, the top level, then we say, okay, the condition is met. If that condition is met, then we're going to step into the next level, which is another decision there. And then we have another else statement sitting there. So we have a if, then we have a else on there. Whilst if we come to the top, we're saying that if it is false, so if we escape this, then we have our condition that will be run, and that will be this condition. And I hope it's okay up to this point. So we have another concept, which is a loop. Earlier on, when we're talking about cache, we can simply say, you want to check, you have a while loop, you say while s is greater than, sorry about that, while x is greater than 10. Let's do it, let's write a proper one. Actually, we can still work with this, so let's work with that. So while s is greater than 10, so I have my while. We can say print something or blink an LED. Let's use my term. So blink an LED. Then in there, we will just do x minus minus, well, which is equal to x equals x minus 1. Yeah? And if before this x was 20, it will just put it to it, and then it will start from x equals 20, run the loop, and it will subtract 1 from it. It will just continue repeating it until x is less than 10, and then it will skip this. So how do you represent that using a flow? We've got the expression. If it is true, which means if x is still greater than 10, it will go back up, then run it until x becomes less than 10, and then it will just skip to this particular point and continue the coding for us. Sorry, if that's the question, simply ask, because I can't see the chat. Otherwise, I'll continue. So you have an example. We use blink and LED. You can put blink and LED in there. So you have a number that is less than 10, and we just check in printing hello or blink and LED there. It will just add 1. Then you go keep doing so until it's greater than 5. Then it will skip on to this point. Just another example of while loop, and we have a do while, right? So do while loop, you can think of it as a password managing system. So if you want to check your password, so basically it will just ask you to input your password. So you input the password for the first time, you just input your password, then it will check the value of your password, and it will probably tell you that you have an error in the password. So maybe you say error, then it will just ask you to input your password again. So input password again, then it will check the password again for you. So you just say while the password is less than that. So what you are seeing in this particular case, it runs at least once. So first of all, we check, is the password there? Then it check first. Check the password before it actually gets stuck in a loop. Otherwise, if your password, of course, was correct, then it will skip all that into the next step for you. So quite similar to the while loop. If you are actually a Python programmer, you realize that you don't have a do while in Python, but you have at least in C++ and other things. So you have the statement first going out, then you come back to checking the condition. So this statement will run at least once, right? Because it will take your password at least once. And before it does the condition checking, then it goes back up for you. So just an example, we've used a password example, so I'm happy to skip this. Or in the case, if we take the case of, let's go through it, the case of the count earlier, quite similar to what we have with the while loop, the same diagram. But the only difference here is that we will go through the first step within the do while where we assign, and then we do one count, the value to the count before we just check the condition, then go back and then we perform the increment. But we don't go back to the statement that ran at least once. Similar to while loop, we have a for loop. So in C++, we can have something like a for int, which is an integer data type. We'll talk about these at some point. Int I, just a variable I, equal to, just giving it a new value, maybe I equals to 0 to I less than maybe 10. Then we'll do something like I++, which is simply I equals I plus 1, okay? So I++, which is just equal to, which is the same as I equals I plus 1. So what this is going to do is it will initially assign I to 0. Then it will perform whatever task we have put in this brace or this bracket there. So perform whatever is there. Then as soon as that task finishes, I will increment to what? 1. And it will do it again. I will go to 2. It will do it again until I is, let's say, I less than equal to 9. Before it will be equal to 10, before until 9, or until 10 in this particular instance. And then it will just go on to, it will just exit the loop completely. So we notice that we are, of course, assigning the number, which is the initial stage, and sometimes it can be I minus minus as well. So it doesn't necessarily have to be the minimum number, but the starting number I'll go with, right? So go with the starting number, and the max number, I'll change that to the end number, right? So it's the starting and the end value. So we assign the starting value, and then, of course, that will go into a check to see whether it's reached the end yet. If no, then it will perform whatever task that you want it to perform. Then it will go back to increment with the increment set. I think something is missing. If nothing is missing, I can just fix it. Then it will just perform the increment. In this particular case, you have the increment on there, and then it will come back and keep checking the loop before it finally, of course, it finally falls, or it doesn't satisfy the for loop again before it goes to the next one. So yes, that's the increment that was missing from the previous slide. So we just inserted the increment here. I'm glad I actually put it there so you can have a reference for yourself. Example of the for. I think this one we can also skip that because it's just pretty much example which we have seen example for ourselves. And that actually takes us to the end of the set